So that the magnitude of the velocity fluctuation of the electron beam is directly proportional to the magnitude of the axial electric field in a helix TWT. That's our question. We have seen that the principle of working includes velocity modulation in a helix TWT. Okay, so or we call it as velocity fluctuation. That is how much variation that velocity undergoes in the electron beam. You have to show that the magnitude of that velocity variation of the electron beam is directly proportional to the magnitude of the axial electric field in a helix TWT. So, read and understand. That's your question. I have written it down. The answer comes like this. Answer here you have to start with the traveling wave. So let we assume that the traveling wave in the TWT is traveling in the Z direction. Always we start with assuming Z direction as the direction of propagation for any wave. Usually that is the case. So here also we start by assuming the traveling wave in the TWT. I hope you can read this, read my handwriting. Okay. Anyway, problem I have given it to you written notes. Let the traveling wave be traveling in the Z direction. So the Z component of the electric field can be expressed as Ez is equal to E1 sine omega t minus beta p into Z. Beta p it is. This beta p. Okay. Beta p into Z, where E1 is the magnitude of the electric field in the Z direction. Magnitude of the electric field in the Z direction. Beta p is the phase constant given by omega by Vp, where Vp is the axial phase velocity of the wave. Okay. So what are the things which are given? We assume that the wave is traveling in the Z direction. The Z component of the electric field is expressed as Ez is equal to E1 into phase term, phase angle term, that is sine omega t minus beta p into Z, where beta p is the phase constant given by angular frequency omega by phase velocity. Vp is the actual phase velocity of the wave. E1 is the magnitude of the electric field in the Z direction. Okay, these are the initial things which we assume. Now, moving on to the next step, that is, you know that the equation of motion, according to Newton's principle, it is mass into acceleration, or m into dv by dt. Rate of change of velocity, as you know, it is acceleration. So m into dv by dt will be given by E into electric field. That is, force is equal to, we have learned the equation, F is equal to E, where E is the having the negative charge. E is the charge of the electron. Capital E is the electric field. So according to that equation, we can write the equation of motion of the electron as m into dv by dt is equal to minus E into capital E. What is capital E? E1 sine omega t minus beta pz. Just now we have assumed that this case here according to this equation. So we get m into dv by dt is equal to minus E1 sine omega t minus beta p into z. Now let the electron velocity be given by an equation for velocity modulation, which we have learnt earlier. What is that? V is equal to V0 plus VE into cos omega ET plus theta E. How did we get that? This is the sum of the DC velocity, electron velocity V0 plus that variation. You know, velocity is getting modulated, isn't it? So you have the DC electron velocity component plus that sinusoidally varying component. So it's an AC, total AC term. So electron velocity is given by is equal to, this is the equation for the velocity modulation, which we have learnt earlier. While learning Klystron, we derived this. So V is equal to V0 plus VE into cos omega ET plus theta E, where V0 is the DC component, DC electron velocity, initial one. Then VE, small VE is the magnitude of velocity fluctuation in the velocity modulated electron beam, this VE component. Okay. Then omega E is the angular frequency of velocity fluctuation, and theta E is the phase angle of the fluctuation. Okay, all these things are given, we assume. So this is the equation for the velocity modulated electron beam, which is sum of the DC electron velocity plus the AC component, which is or the fluctuating component. So small VE is the magnitude of velocity fluctuation in the velocity modulated electron beam. Omega E is the angular frequency, and theta E is the phase angle. Okay. Now, for the electron beam and the electric field to interact, that is what is happening in a TWST, isn't it? The electron beam and the axial electric field, and you know the electric field that is being produced by the input signal, and due to the permanent magnet that is present in the TWT. So we want the electron beam and the axial electric field in the helical TWT structure to interact. For this, the velocity of the velocity modulated electron beam must be approximately equal to the DC electron velocity. Okay, that is a condition for the electron beam and the field to interact. That is, the velocity modulated electron beam must have a velocity which is approximately equal to the DC electron velocity. That is, V must be approximately equal to V naught. And the distance traveled by the electron, as you know, it is given by velocity into time. Let us write it as Z is equal to V0 into T minus T naught. Okay, T naught is the initial time. So in general, Z is equal to V0 into T minus T naught. So what we can write according to the previous equation, we can substitute here m into dV by dt, taking dV by dt from here, from this electron velocity expression, and taking the right hand side as such. What do we get? Taking m into dV by dt, we get m into VE omega E sine omega ET plus theta E. How do we get that? M into dV by dt. What is dV by dt? Differentiate this expression. Dv by dt will be, this will be constant, then so 0 plus Ve into omega E into sine omega t plus theta E. Okay. That's what we get. So you get the Can you hear? Or did we lose the connection? Are you able to hear? Yes? Abhirami? Oh, okay. Okay, I thought I thought we had lost the connection with a power wire. Okay, so we'll continue. So taking that dV by dt and putting that component here, that equation here, instead of dV by dt, we write VE omega E into sine omega ET plus theta E. And on the right hand side, it is the same, E into E1 into sine omega t minus beta P into Z. Instead of Z, we write V naught into T minus T naught. That is the equation. Beta P into Z. Z in the we write V naught into T minus T naught. Now we have equated the two sides of the equation and comparing similar terms on both sides. And LHS is equal to RHS. So we can compare the similar terms and equate them. So what do we get? The amplitude term, first of all, M into VE into omega E should be equal to E into E1. Okay. So what do we get here for the first term? E by M into, so VE we can write, the fact that is the first term, we get M into VE omega E is equal to E into E1. So comparing that term, we get VE is equal to EE by M into omega E. That's the first equation. So what do we get? M into VE omega E is equal to E into E1. That means comparing, we get VE is equal to E by M E1 by omega E. Okay, that's the first equation that we get. Number it as 1. So that is what we have written here. From here, we get V is equal to E by M into E1 by omega E. So actually, we have arrived at our answer. Okay, we have got our answer, but we can compare the remaining terms also. That is comparing the remaining terms here, omega E. Next. That is comparing the terms, that is this for the amplitude magnitude term. Now for the phase angle, omega et should be equal to those corresponding terms in t on the right hand side. So what do we get? Omega et should be equal to, here you have an omega t minus beta p v naught t. Okay, but so that we can write omega, what do we write now? I'll just stop this. First equation we have already got. Omega et equal to what? Omega et is equal to omega t minus beta p v naught t. Comparing the terms, omega t minus beta p v naught t. Okay, that we get. So cancelling t, what do we get? Omega t. Omega is actually from earlier equation, omega is Vp into beta p, that we have written first in the first slide, didn't we? See, beta p is equal to omega by Vp, or omega is equal to beta p Vp. So instead of omega, we can write beta p Vp into, that means therefore omega is equal to, we cancel out t, beta p Vp minus beta naught v naught. Not beta, beta p, beta p v naught. So what is that? Beta p into Vp minus v naught. Okay, this we get as the second equation. That is what is written here. See, the second equation, omega e is equal to beta p into Vp minus v naught. And similarly, comparing theta e term. So here theta e means, here we get beta p v naught t naught. That is the third equation. So comparing the three terms, you get three equations finally. And from the first equation, Ve is equal to E by M into E1 by omega E, that I have written here once again. That is equation 1 is Ve is equal to E by M into E1 by omega E, which shows us that electron velocity Ve is directly proportional to electric field E1. Okay, so we have arrived at our answer. So this is our answer. We have proved that our velocity fluctuation is actually directly proportional to the electric field that is applied. Okay. So our question is, answer is complete now. Now, moving on to the next question. Our next question will be, your question is, derive the electronic, question is derive the electronic equation of TWT. Electronic equation. Okay, derive the electronic equation. Or another way in which the same question can be asked is, derive the expression for the convection current induced by the axial electric field in a helix TWT. That's a question. It can be either asked as derive the electronic equation or derive the expression for the convection current induced by the axial electric field in a helix TWT. Okay, that's a question. You can refer to the notebooks I have, notes I have given. The derivation comes there. Actually, it is a long derivation. You can look at the steps and learn or listen. So, you know the electron velocity, the charge density, current density. What are the things which we assume? We assume the electron velocity, then let us take the electron velocity as v is equal to v0 plus v1 e raised to j omega t minus gamma z. Then charge density as rho equal to rho 0 plus rho 1 e raised to j omega t minus gamma z. Then current density as j is equal to j0 plus j1 e raised to j omega t minus gamma z. Then finally, the electric field, axial electric field, Ez is equal to E1 e raised to j omega t minus gamma z. These are the things we assume at first. We assume that the electron velocity is given by this because it is a modulated term. Okay, having a DC component and a sinusoidally varying component. Okay, so charge density rho. Similarly, rho 0 plus rho 1 e raised to j omega t minus gamma z. Current density J is equal to J0 plus J raised to j omega t minus gamma z, and Ez is equal to E1 e raised to j omega t minus gamma z. Okay, these are the four equations where gamma is equal to, it's the propagation constant given by alpha e plus j beta e is the propagation constant of the axial waves. J0, it is the current density, it is negative to indicate J0 is positive in the negative z direction. So, if we take the negative z direction, then J0 is taken as negative. J0 is positive in the negative z direction. That means J0 is negative in the negative z direction. Sorry, it's the other way around. J0 is positive in the negative z direction. That means J0 is negative in the positive z direction. That way, opposite. Okay, that's how it is taken. The direction sense is assumed here. Okay. Now, for a small signal, the electron beam current density will be given by, for a small signal, the current density, electron beam current density is J is equal to rho v. As you know, it is current charge density into velocity. J is equal to rho v. You know that equation, isn't it? Current density is equal to charge density into velocity, which is equal to, that is taking the product of the two equations. Rho v nu parnal, you multiply equations 1 and 2. Okay. So rho 0 v0, multiplying them, you get v0 rho 1 plus v1 rho 0 into e raised to j omega t minus gamma z plus v1 rho 1 e raised to 2 j omega t minus gamma z, multiplying the equations, which is approximately equal to rho naught v naught plus v naught rho 1 plus v1 rho naught into e raised to j omega t minus gamma z. That is, we neglect the higher order term. This e raised to 2 j omega t term, that is neglected. Mark this as equation 5. Now, this is approximately equal to minus j naught plus j1 e raised to j omega t minus gamma z. According to our equation, we had written earlier for current density, where minus j naught is equal to rho naught v naught, j1 equal to v naught rho 1 plus v1 rho naught, and rho 1 v1 approximately equal to 0. We assume that. Okay. Taking that, that third term being neglected, rho 1 v1 approximately equal to 0. Mark this as equation 6. Okay. Now the force equation, as before, we write the mass into acceleration force equation. Force equation m into dv by dt is equal to minus e into e1 sine omega sine or e raised to that form. We can write. E raised to j omega t minus gamma z. Okay. Mass into acceleration. This is equal to m into d by or dou by dou t, m into dou by dou t plus dz by dt into dou by dou z. You just manipulate that d by dt term as dou by dou t plus dou dz by dt, dz by dt into dou by dou z of v, where v is equal to v0 plus v1 e raised to j omega t minus gamma z. We simply manipulate this d by dt term as like this in terms of partial differentiation. Then in the next step, therefore dv by dt is equal to minus e by m into e1 e raised to j omega t minus gamma z, that is equating both sides, which is equal to dou by dou t plus dz by dt into dou by dou z into v0 plus v1, that is we expand, minus instead of v we write that its original equation. Now again finding out the partial differentiation and compare, finally taking the derivatives, that is finding out dou by dou t of this, then dz by dt and dou by dou z, you get the final equation as j omega minus gamma v naught into v1 e raised to j omega t minus gamma z when you perform that partial differentiation. Therefore, from which that is equating the two sides, what do you get? v1 is equal to, that is equating this to this side, v1 equal to minus e by m into e1, you are equating this to this side, okay, by j omega minus gamma v naught. Okay, mark this as equation 8 and this one as 7. Okay, so this is now next, by law of conservation of electric charge, law of conservation, charge can neither be created nor destroyed. The continuity equation, we also have learnt about the continuity equation. Continuity equation is del dot j plus dou rho by dou t is equal to 0. It can be written as del dot j plus dou rho by dou t, which we can write as minus gamma j1 e raised to j omega t minus gamma z, that is finding out del dot j. J expression you have already written before, isn't it? 3, equation number 3. Refer to that. Plus j omega rho 1 e raised to j omega t minus gamma z equal to 0. Mark this as equation number 9. So, which is equal to minus gamma j1 plus j omega rho 1 into e raised to j omega t minus gamma z. Or therefore rho 1 is equal to, comparing the two sides, minus j gamma j1 by omega. Mark this as equation number 10. Now substituting 8 and 10. What is 8? This is 10. 8 is this equation. 8 and 10 in equation number 6 here. That is the equation for J1. Substituting. So next step is what? Substituting 8 and 10 in equation 6. What do we get? What is 6? Equation number 6 is J1 is equal to rho 1 V naught plus rho naught V1. Okay, substituting that, we get J1 is equal to minus J by omega gamma J1 V naught plus rho naught into minus E by M into E1 by J omega minus gamma V naught. Since minus J naught is equal to rho naught V naught. Now, this again manipulating this equation, finally we will get an expression for J1 as J into omega by V naught E by M E1 J naught by J omega minus gamma V naught whole square. Mark this as equation number 11. This is the final equation which gives us the magnitude of axial electric field, current density J1. Now the magnitude of the axial electric field is uniform of the cross section area of the electron beam. Then the spatial current. Now we have to find out what we have to find out. We have to find out the current. So the spatial AC current will be proportional to the spatial AC current I will be proportional to the DC current I naught with the same proportionality constant for J1 and J naught. So in the next step, we assume let beta E is equal to omega by V naught be the phase constant of the velocity modulated electron beam. Let that be the phase constant, where we know that V naught is the velocity of the electron given by root of 2e V naught by M, okay, which is 0.593 into 10 raised to 6 into root of V naught, capital V naught, where capital V naught is the DC value, DC field that is applied. So therefore, from 11, equation number 11, which we have obtained just now, manipulating that equation, I have written down the steps in the note. J1 is equal to J omega by V naught into E by M into J naught by J omega by V naught minus gamma whole square into E1 by V naught square. Now, in that you substitute this V naught equation, root of 2e V naught by M, and omega is equal to, or beta is equal to omega by V naught here. You replace it and substituting these two and manipulating, finally you arrive at an equation for J1 as, finally you will get J1 is J beta E J naught E1 by 2 V naught to capital V naught into J beta E minus gamma whole square. This is the equation. So the convection current equation, we can now write convection current I is now given by I is equal to J beta E I naught. Instead of J naught, we can write I naught E1 by 2 V naught into J beta E minus gamma whole square. So this is the final expression or the electronic equation. That is, you have to derive until you get the convection current. Okay, this is the convection current equation for the helix TWT. Okay, that's it. Now one more thing. So we have learned two derivations and plus certain important formula also you have to learn in TWT, because you might be asked to work out certain problems. Important formula in TWT, simply write them down or learn them by heart, where the gain parameter gain parameter C is equal to I naught Z naught by 4 V naught raised to 1 by 3. See, learn this formula. Gain parameter C, I naught Z naught by 4 V naught raised to 1 by 3. Where then output power gain, another formula is for output power gain AP is equal to minus, no derivation for all these, simply learn the formula. This is the formula, minus 9.54 plus 47.3 N into C. We will write what is meant by each term. Then C is this gain parameter. Okay. N is the circuit length. We are coming to that. Then that is this. Okay. I naught is the beam current. I naught is the beam current. V naught is the beam voltage. Z naught should be the characteristic impedance of helix. Then N is equal to L by lambda E, which is the circuit length, N, capital N, which one that is given here. It is L by lambda E, and beta E is the phase constant. So, 4 more formula are there. You have 4 propagation constants defined for the helix TWT. 4 propagation constants are given by gamma 1, gamma 2, gamma 3, and gamma 4. They are given as, it is a big formula actually, no other way than to memorize. So these are the 4 formula. Even though they are easy to remember because some of them you simply have to change the sign. J beta E into 1 minus C. Then gamma 4 is equal to minus J beta E into 1 minus C cube by 4 C. These are the 4 propagation constant formulas, where beta E is equal to omega by V naught. Okay. 0.593 into 10 raised to 6 into root of capital V naught. Okay, where capital V naught is the DC voltage. So these 4 propagation constant and plus the gain parameter formula C and output power gain in dB. Here, output power gain in dB, AP. That is equal to minus 9.54 plus 47.3 N into C. What is N? It is the circuit length given by L by lambda E. So L and lambda E will be given. You can find out N. Okay. So 2 questions also I have worked out and given to you in that problem. The question was, first question was, helix DWT operates at 4 gigahertz under a beam voltage of 10 kilovolt and beam current 500 milliamps. This is a worked out problem from the textbook only. If the helix impedance is 25 ohm and interaction length is 20 centimeters, find the gain parameter. Find gain parameter. What is gain parameter? C, and output power gain A. So these things are given. 4 gigahertz is the operating frequency, beam voltage, beam current, impedance, and length. L is equal to 20 centimeter. So what we can calculate? We are asked to find out C and A, isn't it? So C expression is I naught Z naught by 4 V naught. So what is C? I naught you are given 500 milliampere. Z naught also you are given 25 ohm by 4 V naught. V naught is also given 10 kilovolt, isn't it? So simply by substituting and calculating, you can find out C. C is equal to I naught Z naught by 4 V naught raised to 1 by 3. Simply substitute the values. I naught is 500 milliampere, Z naught is 25 ohm, okay, and V naught is 10 kilovolt. Okay, substitute them, you calculate, find out C. Similarly, you are asked to find out A. To find out A, you need output power gain AP. Now, minus 9.54, you will be getting this in dB only, plus 47.3 NC. N is L by lambda E. N you have to calculate here. So, N is equal to L by lambda E. What is that? L is given 20 centimeters. 20 centimeter by lambda E. Lambda E also you have to find out. Lambda E is equal to 3 into 10 raised to 8 meter per second by frequency given 4 into 10 raised to 9. How much is that? You get it as 7.5 centimeters. Okay. So you got lambda E 20 by 7.5. You get N is equal to 20 by 7.5, which you get as 2.6 N value. So you can easily calculate A value as, so A is equal to minus 9.54 plus 47.3 into N into C. C you have already found out, N just now you got. So this is minus 9.54 plus 47.3 into 2.6 into, what is C? C, you might have got it earlier. Okay, substitute that value, you will get the answer. Find out. Okay. That is a question. This has been asked previously for your exam. That's why I discussed it here. So one more question. I want you to do it by yourself. A TWT has V0 is equal to 3 kilovolt. This is the second question. 3 kilovolt. I0 is equal to 30 mA. Z0 is equal to 10 ohm. N is equal to 50. Here N is given. F is equal to 10 gigahertz. Calculate gain parameter C. First one, calculate C. 2, power gain AP. And 3, 4, propagation constants. Gamma 1, gamma 3, gamma 4. You are asked to find out all these. The first two you can easily do. Just now we have done. For finding out 4 propagation constants, you have to apply this formula. Which one? Here. Okay. So calculate that also. Find out the answers. That I am leaving it to you as homework. Okay. This question. Please do it. So with that, our TWT portion is over.